we want to prove that the quantity 11 to the n plus 2 plus 12 to the 2n plus 1 is divisible by 133 for all n greater than or equal to 1. So this will be done by induction. So we will first show that the statement is true for n equals 1. So what we're going to do is we're going to plug in n equals 1 and see what we get. We should get some number that is divisible by 133. Now what does that mean? It means that that number is equal to 133 times something. That's what we're going to be looking for. So, setting n equal to 1 yields 11 to the 1 plus 2 plus 12 to the 2 plus 1. So we have to somehow make this something times 133. So you can think of 11 to the 1 plus 2 as 11 times 11 squared. But what is 11 squared? 121. And 12 to the 2 plus 1, similarly, we can think of that as being 12 times 12 squared, where 12 squared is 144. So what we're doing is we're breaking this up in a way that hopefully we can see a 133 in there somewhere. And I think we're going to get it. Because 144 is 133 plus 11. So if I gather all the terms that have an 11 on them, we have 11 times 121 plus 12, because again we have 11 times 121 and 11 times 12. And then we have 12 times 133. But what is 121 plus 12? That is 133. So what I end up with is 11 times 133 plus 12 times 133. So this ends up being 23 times 133. So what we just did was we plugged in n is equal to 1 into the original expression, and we get something times 133. So this completes the basis step. So now for the inductive step. So what we will do is we'll assume that the statement is true for some k. So what I'm saying is this. We assume that there is a natural number d such that (11 to the k plus 2 plus 12 to the 2k plus 1 equals 133d. Because again, what we'd want to show is that 11 to the n plus 2 plus 12 to the 2n plus 1 is divisible by 133. So that means we want to show that this expression can be written as 133 times something. So this right here is the inductive hypothesis. So we assume that this statement is true. And then we will then show that what? Well, we replace k with k plus 1, we give us 11 to the k plus 3 plus 12 to the 2k plus 3. So we're going to say that this, we want to show that this is divisible by 133, which means it's equal to 133 times something, but it's not going to be the same d. So we're just going to say, we will then show that this is going to be equal to 133 times something, or just, we're going to show that this is divisible by 133. So we have 11 to the k plus 3 plus 12 to the 2k plus 3 equals. So we have to somehow break this expression down in terms of what we have in the inductive hypothesis. I can take out an 11 here. This is 11 times 11 to the k plus 2 plus 12 squared times 12 to the 2k plus 1. We're using properties of exponents. So using the inductive hypothesis, we have 11 times 11 to the k plus 2. I can replace that. I can replace 11 to the k plus 2 with 133d minus 12 to the 2k plus 1. Go back and look at what the inductive hypothesis is. So we have 11 times the quantity 133d minus 12 to the 2k plus 1, and then plus 12 squared, which is 144, right? but 144, isn't that 133 plus 11? That's a trick that we used in the basis step, I think. So I replaced 12 squared with 133 plus 11, and I replaced 11 to the k plus 2 with the quantity 133d minus 12 to the 2k plus 1. So we will combine terms like we did before. Notice that we're going to have some things cancel, right? (11) times negative 12 to the 2k plus 1, and 11 times 12 to the 2k plus 1. They are going to cancel. Okay, that's what you should notice. Now notice, normally in a proof, we're not going to be circling things in red. That's not part of, I'm just trying to demonstrate what's happening when you submit a proof. You want to submit something that's very clean, okay? We can talk about that more in class. But the next step, as you see, is going to be what we have: 133 times 11d, and then a 133 times 12 to the 2k plus 1. That's what's going to be on the next line. So when you combine everything, you end up with 133 times the quantity 11d plus 12 to the 2k plus 1. So the d is there because, remember, we were assuming that the original expression in terms of k was divisible by 133. So that's still in our expression. So when we are doing the inductive step, which is the k plus 1 case, we see that that case gives us 133 times something. So this is actually what we wanted. We wanted to show that that expression was equal to 133 times something. So we say now that this completes the inductive step and the proof.